Hello everyone, I am Professor Amit Solanki, Department of Electrical Engineering, SND College of Engineering and Research Center, Yeola. Today we will discuss the topic that is the dynamics of motor load system of the first unit of the subject PECD. In previous class we have discussed about the advantages, disadvantages and applications of electrical drive system. Now we will move towards the dynamics of motor load system. This is very useful and important topic for the electrical drive system. So in that we will see how to motor load system is connected or related. So when an electric motor rotates, it is usually connected to a load which has a rotational or translation motion. And the speed of the motor will be different from that of the load, right? And the translation motion, the position of the body changes from point to point in the space, and the speed of the load may be different from that of the motor. And if the load has different parts, so their speed may be different. In some part of the rotor may rotate while others may go through a translation motion. So in that part of dynamics of motor load system, so motor generally drives a load, or that means a machine, through some transmission system that for the with the help of shaft. Okay, and the load speed may be different from that of the motor. And it is convenient to however to represent the motor load system. So in that figure you can see here, we will observe this figure. This is the motor and this is the load. In that you can see here that is a J. What is the meaning of J? The J is stand for the moment of inertia of the motor load system. This is the overall moment of inertia in kilogram meter. Omega m is given by, that is the angular velocity of the motor shaft in radian per second, and T it is the, we can say that the motor torque in Newton meter. T of L, it is also the load torque referred to the motor shaft given in Newton meter. Any motor load system can be described by the following fundamental torque equation. So this is the fundamental torque equation. According to this torque equation, it is given by T minus TL is equals to d of dt bracket j omega n. So we can rewrite this equation in the form of this, that is the j of d omega m upon dt plus omega m dj upon dt. From this equation, we can conclude that the above equation is applicable to variable inertia drive used in mine windows, industrial robots, etc. But for the constant inertia, in that case, if constant inertia, so dj, the quantity dj upon dt is equals to 0. So therefore, our new torque equation will be T minus TL equals to j of d omega m upon dt. And we can write this equation in again this form, that is a T equals to j of d omega upon dt plus TL, where T, capital T, is the stand for motor load torque, motor torque, and T of L is indicate the load torque. So from this equation we can conclude the idea. We can say that the torque developed by the motor is a counterbalanced by the load torque, and this there is a quantity one, that is a dynamic torque, that is a j of d omega upon dt, and this term j of d omega upon dt is called the dynamic torque because it is present only during the transient operation. So this is all about the concept of the dynamics of motor load. So in case of, if we are observe here, according to this question, the acceleration and deceleration of drive depends on the value of motor torque and load torque. So in case of acceleration, motor torque is greater than load torque, and for deceleration, motor torque is less than load torque. So during acceleration, the motor torque not only overcomes the load torque, but it supplies to dynamic torque. That means J of d omega upon dt to overcome the drive inertia. In this drive with large inertia, like electric trains, motor torque must exceed the load torque. When fast transient response required, the motor torque should be maintained at larger rate and the system should be designed with lowest inertia. The energy associated with dynamic torque is stored as kinetic energy, assists the motor torque T and maintains drive motion. So thanks a lot for watching this video.